In the first luncheon keynote titled Oceans and Ice, Prophets of the Planet, we'll hear from Julienne Stroeve, a senior research scientist at the University of Colorado's National Snow and Ice Data Center. Dr. Stroeve has a PhD from the University of Colorado and is the author of more than 20 scientific papers. Current research includes monitoring the causes behind the rapid decline of the Arctic sea ice cover and investigations into how the transition towards a seasonally ice-free Arctic will impact our climate. Her work has been featured on the Discovery Channel and History Channel. Let's welcome Dr. Julienne Stroeve.
Great, thanks Lucy for the introduction. It's great to be back in Aspen. I think I've participated in probably, 10 AREDAY events. This will be, I guess, the second time I'm giving somewhat of a science talk. But it's more to just talk about what is going on this year, mostly focused in the Arctic. And one of the reasons why I study this region is because we've always understood that if the planet is warming, we should probably see changes happening first in regions like the Arctic or the Antarctic, because these regions are very sensitive to climate change because they're covered by snow and ice, and they reflect most of the sun's energy back out to space. But if the planet is warming, you're going to start melting that snow, and you're going to start melting the ice, and the planet is going to warm further because of a loss of this reflective sort of blanket that covers the planet. So I know last year was our hottest year on record, and 2016 is slated to become, again, the hottest year on record. But you may not know that in the Arctic, we've also been setting a lot of records this year, and especially this winter. If you've seen any of the media, there's been several media stories talking about these record warmth that we've had this winter in the Arctic. There was Climate Progress on March 13th that said, record-shattering February warmth bakes Alaska. Arctic 18 degrees Fahrenheit above normal. A couple days later, The Guardian wrote, record-breaking temperatures have robbed the Arctic of its winter. And if you look at that spatial map there, you can see what the temperatures were like in February this year. The planet has been warm, but it's been really amplified in the Arctic. And of course, what that has done then is led to record lows in our sea ice extent that covers the Arctic Ocean. And in fact, we had a record low for January, for February, for March, and this was surpassing last year's previous record low for the winter maximum extent, which also made a lot of news. And it's been interesting because in wintertime, we don't really see these large changes in the sea ice in the Arctic Ocean. We still expect temperatures to be cold enough in the winter to freeze the ice, even if it's a thin layer of ice. But these winter changes are actually starting to become more interesting, especially because they're really based around the Kara and the Barents Sea. So if you look over there by Siberia and Eurasia, that's where the ice has been low in the winter. And this is important for a couple of reasons. One is this is a really active region for the Norwegians and the Russians for oil drilling and resource extraction. It is also maybe a region where some scientists have hypothesized that having less ice in that region in winter is causing this warm Arctic cold continent phenomenon. So these more severe winters that some have experienced in Siberia and maybe even the northeastern United States could be linked to less sea ice in that region. Now, because we've had these record lows this summer in the sea ice, it's actually persisted through May. And so the Washington Post had an article the other day about that we've never seen anything like this, record low for May. And it was quite striking in terms of our long-term satellite data record, which began in the 1970s, in that this May was about 1 million square kilometers less sea ice than we have seen at any other previous record low. So there's obviously some idea that maybe we're going to have the lowest summer sea ice on record again this year, which would have followed the previous record low in 2012. But another study just came out of the UK saying, well, we don't think that we're going to have a record low this year because they're looking at what the timing of the melt is that begins in the Arctic, and they look at melt ponds as an indicator. So if you have a lot of melt ponds on the sea ice in May, you can forecast that you'll have less sea ice at the end of September. And because the melt is not as advanced right now in terms of melt ponds on the ice, they don't think we'll break a new record. And in fact, if we look now going through June and we look at the curve, we're starting to hit 2012. So we might not be a new record low. But the interesting thing is the last 9 years have had the 9 lowest September sea ice extents on record. There is no recovery. So in 2007, we had our first sort of record low, and it has stayed low, and it's not recovering to anything prior to 2007. We may not be able to predict right now how much ice will be left over in September, even though this is a metric that stakeholders are very interested in. So we're asked, already now, but even back in the wintertime, can we tell stakeholders, so shipping companies, resource extraction companies, how much ice will be left over in September? We can't do that. And part of the problem is, even though you might have very low winter ice conditions, we know that the summer plays a very large role in what's going to happen at the end of summer. So weather is very important. And that is a distinction between climate change and weather patterns. So it remains to be seen what's going to happen, if we'll have a new record low. But I think, if we look at what's going on in the Arctic, and that's the 2012 map of where the ice ended up in September, you can see large parts of the Arctic Ocean are ice-free. What you also see is that you're having regions like the Northwest Passage, which is a shipping route between Canada going up through Alaska, and also the Northern Sea route along Eurasia have been open. And in fact, in 2007 was the first time the Northwest Passage opened. It's been mostly open since 2007, but not every year. The Northern Sea route, on the other hand, has been open every year since 2008. So this is an interesting time in the Arctic in terms of what shipping companies are looking at and reducing the distance between trading between Europe and Asia, for example. But in anticipation of the fact that there probably will be less ice this year, this summer a cruise ship is going through the Northwest Passage. It will be carrying 1,000 people on board. It'll take 31 days to go from New York to Nome, Alaska, and it is planning on going through the Northwest Passage. Now, there's no way to guarantee that they're not going to encounter ice along this route. So obviously there are hazards that they're going to have to pay attention to. And it's not just the sea ice that is a concern, but also the fact that, what sank the Titanic was an iceberg coming from probably Greenland. And so as the Arctic is warm, and we know it's been warm lately, that you're going to have more iceberg discharge from Greenland that you're going to have to pay attention to when you're shipping in that region. So that gets me to just talk about, it's not just the sea ice that is making news right now, but there's also been several stories now about ice sheets. So a new study came out about a month ago, and National Geographic did a story on it in April saying, why the new sea level alarm cannot be ignored. And this has a lot to do with instabilities that we're finding now in the world's ice sheets. So we're looking at Antarctica, we're looking at Greenland, and these are now becoming quite unstable. And studies are continually being updated to look at, what is the sensitivity and what kind of sea level rise can we expect at the end of the century. And from these studies, especially the one that just came out a little bit ago, they're saying if we keep doing what we've been doing and we do business as usual, we are going to probably have at least 6 feet of sea level rise by the end of this century. I mean, that's huge. And that's quite a bit more than we were predicting in the IPCC reports. For Greenland this summer, we've also had some records. It's not just the Arctic sea ice. And in fact, just a few days ago, Climate Progress wrote about how Greenland hits a record 75 degrees Fahrenheit, and record melt is looking like it's going to happen again this year as the globe aims for the hottest year ever. And that's just a temperature anomaly map of where the warmth is happening in Greenland. A lot of it's happening in the northern part, and there was another study that just came out a few weeks ago that was looking at increased melting in the northern part of Greenland that is in part tied to the loss of Arctic sea ice. So circulation patterns in the atmosphere that then change because of the less sea ice can impact melting over Greenland. And this is where your sea level rise comes from, is from the great ice sheets. Not from sea level itself, because if the sea ice itself, because if the sea ice melts, it's sort of like an ice cube in a glass of water. It'll melt, but it's not going to raise sea level. It's the ice sheets that become important. But sea ice plays a very large role in this global heat balance of the planet. So you take that away, and then you're going to probably start melting more of the ice sheets as well. So just to show what happened this year so far, we had a couple anomalous melt events in Greenland. We had in early April, about 10% of the ice sheet started to melt, so that was the first time we'd seen this sort of blip in early April, which seemed to be tied with the time when the sea ice was retreating quite rapidly. Then again in May we had a spike, and then again in June when we had the 75 degrees temperatures over Greenland. Again, how this will play out for the rest of the summer is very uncertain because it does depend a lot on the summer weather patterns, which we cannot forecast at this point. So we can never say how one year will compare to another, but we can look at sort of these long-term projections if we keep warming from greenhouse gases. So just quickly to peer into the future, if we look at these emission scenarios, and this was what was used in the latest IPCC report. So the red line shows you business as usual. So if we keep doing what we are, those are the fossil fuel emissions that we're going to be seeing at the end of this century. The RPC 2.6 is the blue one. That one basically says, starting in 2020, we have to do a drastic reduction in our CO2 emissions and get to zero emissions by the end of this century. Under that emission scenario, we are committed to 1.6 degrees warming. So that's actually a little bit more than the 1.5 degrees with the Paris Agreement. And it really means you are stopping all emissions and you're drastically reducing them quite quickly. Can we achieve this? I mean, I'm not really sure, and that's not the work that I do. But when I look at those curves, I mean, right now we are on a red trajectory. We're not on that blue line at this point. And as a consequence, if we start looking at things like Arctic sea ice, and we look at those future projections, and you look at the red line, the black is the observations, the red line is our forecasts out forward, we're going to lose all the sea ice by the end of the century if we keep doing what we've been doing. Only under the really extreme greenhouse reductions emission scenario, so the RPC 2.6, can we stabilize ice loss at levels that we see today. But you can also see for the first few decades right now, it doesn't really matter which emission scenarios you use, you're pretty much showing the same level of decline until about 2040. But it's really after that point, if we do these drastic emissions, that you can start stabilizing the sea ice loss and the climate implications from doing that. And just briefly to just talk about the Paris Agreement. So I find it interesting because our current emission rates are about 35 gigatons of carbon per year. And we know from studies that we've done is that the sea ice in the Arctic, for example, is linearly related to our CO2 emissions. So that with an additional 1,000 gigatons of carbon, which would be 2 degrees Celsius at the end of this century, we will lose all of the sea ice in the summertime. It'll still come back in winter, but it will be gone in the summer. So the good news, though, is that any measure taken to mitigate greenhouse gases and to reduce CO2 emissions can slow down the ice loss. So it's not that it's hopeless that we're going to lose it all, but it does mean that we have to stick to that 1.5 degree Celsius sort of limit for warming if we want to keep the sea ice. And the same thing is true in terms of sea level. If you do the business as usual, you're looking at 6 feet of sea level rise. But if you do try to mitigate that, you can reduce some of these effects. I think there's a lot of uncertainty with ice sheets, though, because we don't fully understand the mechanisms. There's some studies that suggest that we are already committed to this sea level rise, regardless of what we do. It's a time scale over which that may happen that is a little bit uncertain. So it might take 100 years, it might take 200 years, but that there's some commitment that we already have. And so just before I conclude, I thought this was interesting. So we made a map recently of how much each country is contributing to Arctic sea ice melt. So the very red colors are the countries that show the largest impacts. So, and this is just based on per citizen per capita emissions rates. So you look at the US and Canada, you've got Australia, Saudi Arabia, and even Kazakhstan, which is a bit surprising, are the highest, the countries that are contributing the most to sea ice melt in the Arctic right now. And then I'll just leave with this animation. So it just shows what the temperature projections are. If you do if you're trying to go for the 1.5 degrees agreement, so the 2.6 emission scenario versus just doing business as usual. And as you're going forward in time, at first they don't look very different. But after about 2040, those temperature projections start to diverge quite a bit. And so it just gives you an idea of where we'll be at the end of this century, depending on how we want to handle our fossil fuel emissions in the future. Albert?
So you hear a lot of climatologists say that there's so much heat baked into the oceans that regardless of what we do in the midterm to 2100, we're going to have some pretty devastating effects in the coastal areas for sea level rise. Could you just comment a little bit on that?
Well, that is true. I mean, we do see that even if we do some of these mitigation, like the RCP 2.6, we're still going to see quite a big change in the sea ice and the melting of the ice sheet still. And part of that is just related to instability in the warm ocean waters, which takes a lot longer for that to change. And so, especially with regards to sea level rise, some of these ice shelves that are going to destabilize, we're not going to be able to stop some of that. Exactly how much we're committed to sea level rise, if we were to stop emissions today, I think is a bit still uncertain. But we're still looking at a few feet. Okay, thanks.